In today's session, we are going to resume our last session, second part, and that was the role-based access control. So if I go to my documentation, so role-based access control, we discuss in detail. We discuss the service account, how the if you want to do some automation within the cluster. So if you want to perform some API related task automatically, so then for that purpose, you need to create a service account. And that service account you will associate with some pod and that will perform the activities. So today our agenda point is to understand how we can create a user for the Kubernetes cluster for humans, how humans can interact with the cluster. So normally, whenever any software we are using username password based authentication. But in Kubernetes cluster, the by default behavior is the token based authentication, and for that reason we must have to generate some SSL certificates, and we need some signing authority too. So today we have to understand human users and concept of context. So in last session, if I show you on this channel, Video-17 uploaded DevOps Kubernetes training. We look into cluster events, RBAC, and service account in very detail. But today we have to generate the SSL certificate. So my cluster is up and running. My nodes are up and running healthy. So I create this document, RBAC user creation process. So first of all, we need to understand what is SSL certificate, what is a signing authority, what is public key, what is private key, what is certificate signing request. So these four concepts you should know at least to get started with. Those people who don't know how SSL certificates are working when we are opening any website online. So that website is a HTTPS based, just like if I show you, this is YouTube website, just like this is YouTube. Okay, you can see it's HTTPS based. It means some encryption is happening whenever you are sending traffic to YouTube, and when the YouTube is acknowledging you, everything is encrypted, and that encryption is done by the public and private certificate. The public certificate is available on the public side, mean on the user who are accessing YouTube, and the private certificate is on the server side. Private certificate you will not share with anyone. Public certificate is for the public users. So you can see here the connection is secure. If you click here and you go to connection is secure, a certificate is valid, and you can see what is the certificate issuer, and you can get all the details here, who signed this certificate, and what is the issue date, what is the expiry date of this certificate. Okay, so this is the web-based SSL certificate. So we also have to generate a certificate for the cluster connectivity purpose. So think like you have a domain, you purchase a domain online, you want to host a website, and you want to host that website, and now you want to publish that website just like with HTTPS, not simple HTTP. So you will go to some signing authority, just like GoDaddy, VeriSign. A lot of signing authorities are available online. You have to provide a signing authority only one information, that is certificate signing request. The certificate signing request contain all the information about your certificate, your domain name, your company name, your country name, your city name, the purpose of the certificate, and a subject that contains some information, who is the user of that certificate, okay, and which group you want to use for that certificate. Same thing we are going to perform in our Kubernetes cluster, but the difference is this. The signing authority in this case is our Kubernetes cluster, because our Kubernetes cluster contain our own signing authority, issuing certificate issuing authority. So we will provide this certificate signing request to our cluster, and then certificate, then our public certificate will be issued. So if I just quickly summarize, you should know about the private key, private key. You should know about the certificate signing request, CSR. You should know about the public key, and you should know about the certificate authority. Okay, so here we are going to use all these concepts. So public key is for the public, private key is on the server side. Okay, certificate signing request is just like a request you want to provide to uh, your certificate authority. So AUTHORITY, not ERITY. Okay, so these concepts you should know. So we will perform these steps. So private key generation is your responsibility. Certificate signing request generation is your responsibility. Public key generation is the responsibility of the signing authority. And certificate authority, you can have your own local certificate authority too, just like Kubernetes cluster is providing, or you can, if you are going to make your website application anything publicly reachable, then you must have to sign your certificate via some publicly authenticated signing authority, just like GoDaddy VeriSign. So uh, what is the process? I will use OpenSSL. OpenSSL is a Linux command. It's a tool to generate the private key with some encryption, 2048 or what level of encryption you want to use. If you increase the level of encryption, it will take more compute resource to encrypt your data and decrypt your data. So first of all, I will generate key. So let me just quickly go back to my cluster, and I will create a directory, Asimisan SSL certs. Okay. And I will go in this directory, and here I will generate this certificate. This OpenSSL command you can also install in the Windows or MacBook, anywhere. So now what happened? I generate this asim.ihsan.key. So if I show you, this is my private key. Okay, and you know the permission on this, the operating system knows that this is a private key. That's why it only set the permission for the root user only. Nobody can, other user can see or view this. So now I have to generate a signing request. So certificate signing request, I will use this command. And here you have to understand some concepts. Here this is the certificate signing request. Here in the subject part, this is the container name. CN, I believe, is the container name, or yes, container name, I think. So the just like we create the service account, we cannot create a human user just like service account. So the user actually that is going to communicate with the Kubernetes cluster is embedded into the certificate, and that username we can provide in the subject. Okay, so here CN is the name of the user. Okay, and O, if in the subject part, if I use O, it's the group name. When you will create a role binding and binding based on the group name. So if I use this command, So it will generate, it will use the Asime-san key just I generated. It will create a certificate signing request file named Asime-san, and subject is username Asime-san and group name cluster manager. This group name can be anyone, but just I use this one. Okay, so I am just going to press enter, and you can see the certificate signing request file is also generated. Okay, there are different tools you can decrypt this file, and you can see what information are written in this file. I mean, what user and group name was defined, and the company name or organization name, city. I just skip those information. If I just show you the OpenSSL command help, OpenSSL. I think, yeah, OpenSSL man page, I can show you. So here are some examples how you can generate the SSL certificate. Okay, so, and there will be some examples too that you can use to generate some certificates. So this is a complete list of the parameter, but I just use the parameter just to provide the information related to cluster related certificate. So when you are going to generate the certificate signing request for the Kubernetes cluster, remember this part is very important, because this part contain the username and the group name. Okay, so this user and this group is managed by this certificate that we are going to generate. So now we have generated. You can skip the group too, but at least you should define the username. Now the next step is we have to send this certificate signing request to our Kubernetes cluster so that our public certificate will be generated, public key will be generated. So for that reason, if you are going to sign this certificate from GoDaddy or from VeriSign, you will just log in on your account and you will pay them by credit card, and you have to provide them this signing this file I just generated. And they will issue you 1 year, 2 year, 3 year, 5 year, whatever time you need. The public certificate, and then you can publish on your website. And when someone will open your website, it will not give the error that certificate is not signed. So that authority will validate every time the certificate is signed. But here in Kubernetes cluster, for the signing of certificate, we have to use a Kubernetes resource certificate signing request. If I go to kubectl API resources, and I just grab certificate. Okay, I'm reducing the font size. So you can see this is a certificate signing request. Short name is CSR, is an API resource. False mean it's not a namespace control, it's a cluster-wide resource. So we have to generate a manifest that will, where we have to provide the our information related to signing request, this CSR we generated. Okay, so I am going to generate this file. Since you are familiar with the Linux command line, so you can see I just use cat and a file, everything I just provided, and this file is quickly saved here. Or you can also generate this file manually. So this manifest I generated, okay, the name of this cluster resource, the signing request is Asim Ehsan CSR. You can make its name any name, but it should be like the name of the user for which you are going to generate the certificate. And here base 64 encoded certificate signing request. So this file, its whole content, you need to encode base 64 and you have to put here. Okay, so we can do this activity manually, and then signing name is a signer name. So this is the who is the where we are sending the request, just like we are sending, we can send to GoDaddy, we are sending to certificate authority, and our certificate authority is kubernetes.io and kube API client. This is the signing authority. Okay, and usage for the client authentication. This is the just a syntax for this manifest. Okay, now you are thinking that how we can put this encoded file here. Very simple. We can just encode it with the base 64 command, and we can just generate it and copy paste it here. But for make this step very easy, what I did, save the certificate signing request in base 64 encoded in variable CSR content. So this command, if I just use this command, cat command will open this file and base 64 will encode it. This is encoded now. I can do just copy paste and put in that file, but I don't want to make any mess, because sometime when you are doing copy paste just like this, if you have just done a minor mistake of space or some extra line, that will make a problem for you. So for the safe side, use this command. What this command is doing, this part will encode it, and this command will truncate the additional lines and spaces, and everything will be calculated and will save in this variable. So I'm just going to use this whole command, and it is done. And now if you run env command, so there is a new environment variable just temporarily generated for this session. Yes, it is not here. I can do a echo $sign. You know how to view the environment variable. So this environment variable is temporarily created in this on my session level, and you can see the same value is saved in this variable. But here when I decoded, I cannot calculate where the line is ended, where the line is started, but here everything is calculated. It's a one-liner saved in this variable. Okay, so use this method. Now you save this content in this variable that you have to put here. So in the next step, put the encoded certificate signing request in template manifest. So whatever manifest you have created, you have to throw that variable information in at this location. And to throw this information, just follow this line. This line is doing what magic it is doing. It is using a sed command. Sed, you know, it's a command line based editor of your, you can do editing in command line based if you don't want to open that file. So in the scripting you are using when you want to modify some file by using some script. So here it is replacing this syntax in this file with this variable. As you can read the documentation of sed, and replace this one with this value, and from this file, the name of the file I created, yeah, in this file, and whatever the output is generated, throw to this file. So it will greater than, will create a new file. So I'm just copying, pasting this this command, and so far I have 3 files. So it is going to generate a new file for me. Yes, CSRYAML. If I do a cat, so you can see the same file, but my certificate signing request information base64 encoded, it is provided here. So these 2 commands save our time as well as for any mistake. Now, the next thing is we are ready to pay to GoDaddy to sign our request. So here our cluster, we are ready to ask our cluster to sign this certificate. So what is the way? This is the manifest. This is the manifest. I can simply do, how to apply kubectl, apply -f, and it is going to create a resource, kubectl get CSR, certificate signing request, and this certificate signing request is given to the certificate authority, this certificate authority, to sign and give us the public key. Okay, so right now you can see it's in the pending state. It's means someone as an administrative right need to authorize to generate this certificate. We just put this request to the cluster, but it is not yet approved. Okay, so only power users of the Kubernetes cluster can perform this activity. So because in last session we understand the role-based access. So any user that has a role to use this Kubernetes resource as an issuer. Okay, so if you read the verbs for the certificate signing request API resource, you can get what type of rights you need to give to that user that can perform. But so far, I am logged in. I am communicating with the cluster as an admin user, so I can do anything. I have full rights. So what I will use, okay, so I get the CSR. Now I have to run this command to approve this. So kubectl certificate approve. If you do a kubectl certificate approve, what certificate name? This one. Certificate spell certificate. And it is approved. So now if I get the CSR, you can see its pending state is changed to approved, issued. Okay, now you can see it's approved, issued. Now what I have to next step is our certificate is signed. Now it's just like we paid to GoDaddy and GoDaddy gave us signed this. Now we will ask GoDaddy, okay, it is signed, give me my public key. I paid you. So now GoDaddy will give you your public key by some method. And that public key, then you can use with the private key, this private key. And this pair of keys will be used as a client server communications to make encryption, decryption on both sides. So our certificate is issued. So what we need the public key. Okay, so we see that it is approved. Fetch the issued certificate, this one, public key, public certificate. So from the cluster to do approval. Okay, fetch the issued certificate. So kubectl get CSR. Okay, I ran this command and I can do -OYAML in the YML format, and you can see this certificate is available here. This request is available here. This certificate is issued here. But to fetch this information again, like this way could be a problematic thing. It can create an issue for you. So this whole syntax, actually this certificate, it will give you base 64 encoded. So this command will fetch the public certificate and will also do a decoding and will save in this file. Okay, so I am going to simply run this command. I know my certificate name is Asim CSR. So I will run this command. So this command will get this information in JSON path. Just go to this status.certificate. You can see status.certificate. Go to this part, fetch it, decode it, save it in this file. So in one line, we perform everything. Now you can see after giving payment to GoDaddy, after asking our Kubernetes cluster, they gave us finally the cert file. You can say this a public key. asm.crt. Okay. So this certificate we can publish now, give to publicly for the people who want to communicate with your server securely. So we have done this part. So if I just go back to same thing, we generate the private key, we generate the certificate signing request CSR, we generate the cert file, that is a public key. We ask the certificate authority to do this. Everything is done successfully. So SSL certificate generation part is done here. Okay. Now we have these certificates. When you will get the certificate, what you will do, you will simply publish on your web server like Nginx or whatever web server you are using, you will publish there. But here in Kubernetes cluster, we generate these certificates to generate the kubeconfig file. Okay. And the username is, there is no resource like in Kubernetes cluster like username. If I show you CTL, kubectl, API, sources, pipes and grab, user. No resource like user, no resource like group. Okay, so how we can create the user and group? So the answer I already gave you. The user and group is binded with the certificate you are generated. So you define the username inside the certificate. You define the group name inside the certificate. Okay. So it's mean this certificate has this that is issued by your cluster citing authority. Now this certificate issued with a username built in the SSL certificate. Okay. Now we fetch. Now take a look on the current kubeconfig used. So the new thing you are going to learn here, if we do kubectl help. So there are a lot of options. So there is an option view. There is an option view that we can use to kubectl config, sorry, not view, config. Okay, so kubectl config -help. And you can see, we can view, we can use all these things. So config view will basically do, will show you the file that you are using to communicate with the API server. Which file? This file. Right now, my kubeconfig is this file that I explained you in very detail in very initial sessions. How API server is communicating this file. This file contain how many parts? certificate signing authority data. It contains client certificate data. It contains client key data. But when I ran this command, so the same file that I am using to communicate with the API server is displayed me as it is, but this certificate signing authority data is omitted. Similarly, certificate client certificate data is omitted. Certificate client data is omitted. Rest of all is same. Okay. We just view this what is the format of the kubeconfig file we can create. Okay, so that's why I mentioned this command here. So you can, if you are communicating with the Kubernetes cluster, you should know what is the config file looks like you are using wherever it is. So you don't need to follow the kubeconfig variable and open the file in the notepad. You can use this command. Take a look on the SSL cert directory. Okay, now I explain you in the video when I gave you the overview of the SSL certificate. So you know this directory contains all the certificates. Certificate authority, the Kubernetes certificate related information they generated by at the time of provisioning of Kubernetes cluster. Okay, so this certificate information generate new kubeconfig file. Now, why I listed down here, why I listed down this one? Because we have public key, private key, public key, but we don't have certificate authority file. Where is our certificate authority? So this file path will help you to get the certificate authority file. So I can open a notepad and I can put this whole syntax in the notepad, and I can put here the base encoded cert file, base encoded key file. Okay, here, and I can put here base encoded certificate authority information. So this is the certificate information, certificate authority. Okay, so that I need to base 64 encoded. We have to put it here. So again, I can do this manually. I can create a notepad file. I can open this file and I can do the base 64 encoding and put it here. Base 64 encoding of the of this key file and this cert file. Okay, but this, when you will do this manually, there are about 70–80% chance you can do a mistake. So to avoid these issues, I use this method previously, sed command. I save everything in this one. But Kubernetes is giving us a utility kubeconfig. kubectl config view will show us the current config, and kubectl config set cluster. You know, when I ran this kubectl config, when I use kubectl config --help, so there is a parameter set cluster. Set a cluster entry in kubeconfig, mean generate a new kubeconfig file. Okay, so kubectl config set cluster, name of the cluster, any name you can give. So I am setting here the cluster name Kubernetes. It can be any meaningful name, like my dev cluster, my prod cluster, for some specific application related cluster, any name. But here I am just using the Kubernetes. You can change this name. And then where is my API server? Okay, so it will put in the kubeconfig file, new kubeconfig file. This is my API server. This is the API server port, and it's working on HTTPS. Okay, then certificate authority file is available here. it will automatically, the magic of this kubectl config set cluster is it will read this file, it will automatically decode this in base 64 and will put in the file with proper indentation, everything will be ready. And embedded certs true mean the section of the certificate public and private key will generate and generate the file name like this. I hope you understand this whole command. So this whole command will help you to perform something. No such file or directory. Yeah, I did one mistake. This is a wrong IP. So I know my Kubernetes. How can I read to my API server? My master node IP. Okay, in multi-master cluster, we will do that session too. You will provide here the load balancer IP or your firewall IP. But in this case, right now we are directly communicating with master node. So that's why I put the IP of my master node, and I know the port number is 6443. Okay, so here I will press enter. Cluster Kubernetes set. It's mean a new file is created here, asm-esan kubeconfig. And if I just do a cat to this file, you can see that whole file is created, but only so far the certificate authority related information is base encoded, the server API server detail, indentation, everything is good, and the cluster name of the cluster is given, but the context is null. Config and the user information, public private certificates are missing. Okay, so let's move further. So set cluster configuration. It's just generate the basic file, but it's not the complete file. Set credential for asm-esan. Now I have to provide kubectl config set credentials. If I kubectl config -- help, so you can see set credentials. Set a user entry in kubeconfig. Which user certificate you want to embed in this file, kubeconfig file. So this part is defining that set credentials. What is the username? Username is asm-esan. So how I know this username? Because when I generate a certificate signing request here, I defined the username. So I told you there is no way to create a user in the cluster just like the service account, but user is encoded, saved inside the certificate. So set credential for the asm-esan. Okay, so now username I know is this in my certificate. Cert file is this, public key, private key, okay, and embedded certificate true mean encode it and in this file. This file I already created, so let me just copy paste this file. And I will enter here. Everything seems good. The file names are same. Okay, it's set. Now I will again do a cat to this kubeconfig file. So you can see previously this part was missing. The user part was missing. Previously when I did the cat, this user part was null. Now this user part is provided with the base 64 encoded public and private key. Okay, very good. This is done. Now, the next part is we have to define, set the context. Okay, so kubectl config set context. If I again go to this help, the set context. Set a context entry in the kubeconfig. What is this context? Context is basically defining in your kubeconfig file which user you want to hit, which user or which cluster you want to use to connect, because your kubeconfig file may contain the information of more than one user or can contain the information of more than one cluster. So far, I am creating a kubeconfig file for a single user for a single cluster, but in your professional life, you can have multiple clusters. So you will not every time create switch your kubeconfig variable to different kubeconfig files. Whenever you want to switch to other cluster, you will waste a lot of time. So in professional life, you will have a one kubeconfig file that contain information of all your cluster and all the users of all the cluster. So in that case, the context will help you to switch to different cluster. Okay, so far we have, I am creating this one. I will also explain you how you can create multi-cluster kubeconfig file. The syntax is same, but we will provide the multiple certificate authority, multiple user certificates, and multiple contexts. Each context will separate their certificate authority and user and their certificates. So far we have one cluster and we are creating a one user. So here, let me explain you. kubectl config set context. The name of the context, I am going to set Asim Ehsan context. Okay, this name can be anyone. I refer this context with reference to my username, and you can also set like some cluster name information to like username, then cluster name, and then context. But so far I just have a one cluster. That's why I have not mentioned the name. So it's up to you, whatever meaningful name you can define. And then cluster name. So cluster name, I already told you that we define in the kubeconfig file in very first command. And then namespace. So when this user will jump into the cluster, what automatically the default namespace will be used. So I don't want to use the default namespace. I will use, for example, a dev namespace. Okay, so whenever I am logging into my cluster, the kube admin user getting the default namespace is default. So, but I want to give this user a default namespace dev. Without providing -n, the user can provision the pod into the namespace. And then this -n user that is encoded into our certificate, and then in which file you want to modify. It is updated. If I do a cat to asim.kubeconfig, so you can see now this file is updated with the context information. In the context, cluster name, namespace is defined, and username is defined, and name of the username defined, and name of the context is defined. This is the context section, name of the context, but current context value is empty. So far this file has only one context, but I will also show you the file that contain a lot of context. So in that case, you can put some default context. So whenever you will use your kubeconfig variable, some default context will be selected, and only so all the your kubectl command will go to that context, that specific cluster with specific user. So far in this file, this is not defined. I can put here the context name manually, but by the command line, set this cluster default context, current context mean, I can set use context, the name of the context in this file like this. Okay, if I again open cat, so you see this whole file without opening in VIM editor or notepad. We use kubectl config utility to generate this whole file without any error. So use this method because it will help you to make any mistake in this file. Okay. So now this file is generated. We are done. So user is now created, but do we have any okay, now this file is generated. Okay, now let me pull down this file. Let me pull down this file. Uh, uh, this file name is this. Okay, I will be this file. I'm just changing this information because you know, I have to download this file as an ASIM user because I've logged it with the ASIM user. Then I switch to root. So that's why I'm giving these permissions. So I will pull down this file on my desktop. I already have this file. Let me do this under my C drive. Done. Now to my Windows machine, I will provide the kubeconfig environment variable with this file path. Okay. Now let me open the CMD and let me do kubectl kubectl get node. So error from server, user Asim Ehsan cannot list resource API at the cluster scope. Why this error happened? Because my, let me do Kiko. I think I print this variable. You could fake. No, it's just like percentage. Yes, with percentage. This is a way you can print the environment variable in Windows. So this is a file used. And when by using this file, I hit to my API server, it gave me error. This user does not contain the rights. So when the request go to API server, so API server look, this user have any role or role binding or cluster level role binding? No. So far, I have not created any rights for this user Asim Ehsan. So let me generate kubectl get role in the dev namespace. If you remember, in our last session, we generate this read access role. I just quickly describe this role. Describe role, read access. So you can see I just generate this in the dev namespace. I create this role. That role can have kubeconfig pod secret deployment. Only 4 resources it can manage. It can view only. Okay. Now what I will do, I will bind Asim Ehsan user with this role. Okay, so user, to bind the user, I will generate kubectl, create role binding Okay, hyphen help. And role binding, you know, the name I can say Asim Ehsan binding. BINDING. Asim Ehsan binding. Cluster level role, no. I am using a namespace level of role. And what was the name of the role? Read access. Okay. And username. Which user you are going to associate. Last time we used a service account. That was system user. This is the human user. Okay. So you must have to look my previous video if you are confused with this one. And the username I know in the certificate, I give this username and group name I can also use. I can also give the group name because the group I created in my certificate signing request, I can also use that one. So in that case, if I give that group name uh, to this role binding, then I will just create the further user, any other user in cluster, same like this whole method. Any other user that I will create, I just have to make the certificate signing request with the same group name. Then that user will automatically get this role binding because I will assign the role binding based on group name. But right now I am just doing with the username. So create role binding and the name of the role binding this in which namespace? In dev namespace. So kubectl get role binding in the dev namespace. You can see we use this role binding with the service account, but this time we create for our own user. And if I just do a describe, so you can see it's a user, this user. And why namespace is not written, it's not an issue because you are queuing this role binding within the namespace. Okay, so it's under the dev namespace. And what role is assigned to Asim user? This role. And you can describe this role and you can see what Asim Ehsan can do in this cluster. Okay, so now this part is done. Let me again run this command from my Windows machine. So node still I cannot view, but if I do run pods, so the answer is there is no pod in the dev namespace because by default I am jump into dev namespace because in my kubeconfig file it's written default namespace is dev. And if I do, for example, default, it will give me error that you don't have rights to query to the default namespace. Okay, so by default, I can only query to dev namespace, but there is no pod running. Okay, if I do query to config map, okay, I can query. I can see config map. I think I gave the secret rights to. There is no resource secret. Let me just take a look on what resource here. Secrets and deployments. So if I do a query to DBL deploy, there is no deployment. Okay, so we successfully create a user that can only view in the dev namespace. Okay, so if I do create as an admin user kubectl run pod 123 in dev namespace. Okay, so if I now query get pod, you can see the pod it can view, but it cannot create the pod. If I know white. but it cannot create the pod. kubectl run pod 456 image is equal to nginx. Its default namespace is dev. I don't need to define it. So it cannot create. So let me just quickly kubectl get role in the dev namespace. kubectl edit role in the dev namespace and give me the pod creation rights to this role. Let's see what happened. Pod to deployment get list watch to pod config secret. Okay, so what I will do here, I will add a create. So it can create pod config map and secrets, but cannot create deployment. So just modify this and let me now quickly run this command. You can see now it can create get pods. 2 pods are running. So with this way, we control we can give the user a kubeconfig file. We can generate a kubeconfig files for the users who want to interact with the cluster. So you can give the different rights to different user based on certificates for this cluster. So I hope you got this concept, and this is very important. As a Kubernetes administrator, you must have to create this user, because in the big organizations, the developers, for the developers, you will create these kubeconfig files so that developers can directly deploy their application on the cluster. Okay, so in the next session, we will do the third part of this RBAC. That is the concept of context. So far, if I query from here, kubectl hyphen help, I think it will work. Yeah. Hyphen help config config hyphen help. So config view. So you know which config it will show me, whatever config file I am using on my Windows machine. And I want to see get contexts. So I have only one context in my kubeconfig file. I can have multiple context. Okay, star mean this is a default context, where we can have a list of context, but star will show you which one is currently right now in use, and which context will use which cluster, which user, and that user will land directly in what namespace. Okay. So you can switch to different namespaces. The user can have the role-based access control to multiple namespaces, but so far I gave only the dev namespace. So, or that user can also have a cluster level of role binding, that then that user can, this Asimasan user can jump into multiple namespaces everywhere, whatever you will create. And similarly, the current context I can query. So this command is very important when you are using the kubeconfig get current context. So current context is Asimasan context. Okay, so the number list of contexts are available, so you can query which context you are using. So delete context you can use, or get clusters. How many clusters are available in my kubeconfig file? So this is now you need to create multiple cluster. Then how to embed the multiple cluster in a single file, how to embed multiple user in a single file. This is a separate topic. Okay? But remember, a single file can contain everything. Multiple number of your cluster and number of user for each cluster. So this is the simplest file we created. and we query and we give rights and we verify that everything is connected, and we give some right, we revoke some rights, we see that. So in the next session, I will show you that how I will create one more user, and in the same kubeconfig file, I will add that user, and then we will switch to different context, and different context will lead us with different users. So switching to user is not a concept. Context is basically responsible to switch to different user, and user is then associated with the cluster. Okay. So that's why I told you to give the name of the context meaningful, like username and the name of your cluster. But when you will query it like this, it will also show you what cluster, which user belong to what cluster, and what is the name of the context. So this was our today's topic. I hope you got the point, and see you in the next session.